Hello viewers, welcome to my channel Chemphilic. Let's start 33rd episode of Teaching Chemistry through Riddle. So here is our riddle number 33, which goes like this. A is an important theory related to the speed of a chemical reaction. According to A, reactant molecules which have special characteristics hit each other at specific sites and get transformed into other substance. The transformation is slow at room temperature but increases with increase in temperature. So, this is our riddle number 33. Now, let's see the question. The primary question is, what is A? Guess the answer. The answer is collision theory of reaction rate. Now, the other questions are, the second question is, what is referred here as special characteristics of the reactants? Third question, what is the significance of collision at specific sites? Fourth question, why the rate of transformation increases with temperature? Now, let's discuss collision theory of reaction rate. Now, according to collision theory, for gaseous bimolecular reaction, the reactant molecules collide with each other and give rise to the product. Now, just to imagine, this is the reactant molecules where the concentration is high, and this is the reactant molecules where the concentration is low. High concentration means more number of molecules per unit volume. That means molecules are close to each other. So number of collisions will be more, and more number of molecules converted to product. That means rate of the reaction will be high. So more concentration means more collisions per unit time, per unit volume, and more products are formed. Now, less concentration means less number of molecules per unit volume. So, less number of collision. So, less amount of product formed. So, the reaction rate is low. Now, coming to the failure of this collision theory. See, if collision is the only requirement for the reaction to occur, then the rate of the reaction must be proportional to the number of collisions, or we can say rate constant, which is the rate of the reaction when the concentrations of the reactants are unity, must be equal to number of collisions per unit volume per unit time. But the rate constant calculated from this number of collisions per unit volume per unit time, and for the gaseous reactants, this number of collisions per unit volume per unit time can be calculated from the kinetic theory of gas. So, from this number of collisions, when you are calculating the rate constant, that is found to be much more higher than that of the experimentally determined rate constant. So, this collision theory is modified. What is the modification? Only the activated molecules can give rise to product after collisions. Now, our second question was, what is referred here as special characteristics of the reactants? The significance of these activated molecules or special characteristics of the reactants will be discussed now. See, this is the progress of the reaction along x-axis, and along y-axis this is the energy. Now, this indicates the average energy. Average energy in the sense large number of molecules will be there. Say if you take 1 moles of a substance, 1 mole of a substance, then also 6.023 10 to the power 23 number of molecules will be there. Among those molecules, some molecules will have high energy, some molecules will have low energy, some molecules will have medium energy. Now, if you take the average, then that will give you the average energy. And this is the high energy or threshold energy level. Average energy is always less than this threshold energy. Now, these reactant molecules, they absorb some extra energy or additional energy from the environment, and then after acquiring this extra energy, some of the molecules can reach to the threshold energy level, but not all the molecules, because some molecules have high energy. Those molecules, after acquiring this extra energy, can reach to the threshold energy level, but the molecules which are having low energy, they cannot reach to the threshold energy level. Now, this extra energy is known as the activation energy. So, after acquiring the activation energy, some molecules which are having high energy, they can reach to the higher energy level or threshold energy level, or they becomes activated, and these activated molecules on collisions give rise to the product. And this extra energy, which is known as the activation energy, this is the difference between the threshold energy and average energy of the molecule. So, activation energy is threshold energy minus average energy of the reactant molecules. So, only those molecules which can reach to the threshold energy level can give rise to product after collisions. That's why we call it as activated molecules on collision can give rise to the product. So, all these things what I explained is written here. Now, this hypothetical reaction, A plus A gives rise to product P, or twice A gives rise to product P. And now, the rate of this reaction we can express, that is instantaneous rate we can express minus ddt of molar concentration of A, which is equal to rate constant and molar concentration of A to the power square, because this is second order reaction. All these things I explained in my previous video. Now, when this molar concentration is 1 mole per unit volume, then this rate will be equal to specific rate constant, and according to collision theory, that will be equal to Z into Q. Z means number of collisions per unit volume per unit time, and Q is the fraction of the total number of molecules possessing high energy or threshold energy, which can give rise to product after collision. So, rate constant K is not equal to Z, it is equal to Z into Q. Now, this Z, that is the number of collision per unit volume per unit time, can be calculated from this kinetic theory of gas. So, Z is equal to half square root 2 pi V sigma square n square, where sigma is molecular diameter, V is the average velocity, which is equal to square root 8 RT by pi m, n is the total number of molecules per unit volume, and Q is the fraction of the total number of molecules having high energy, that is n star by n. N is the number of activated molecules or high energy molecules. Then K is equal to ZQ and is equal to Z e to the power minus EA by RT. That means Q is equal to this e to the power minus EA by RT E is the activation energy, R is the gas constant, T is the temperature. So this equation we can derive from collision theory. Now the equation which is derived from this Arrhenius equation. Arrhenius gave one empirical relation between rate constant and temperature. From this empirical relation, if you derive this equation for rate constant, then K is equal to A to the power minus EA by RT. A is the pre-exponential factor in Arrhenius equation, and if we compare these two equations, A is equal to Z. Now our third question was, what is the significance of collision at specific sites? See, for simple bimolecular reaction, that means when the reactant molecules are simple, if we apply this collision theory, that means the activated molecules colliding and giving rise to the product, then a good agreement was found between the calculated value and the experimentally determined K value. But for complex reactant molecules, while number of bonds are there, this agreement is very poor. See, what happens? For complex reactant molecules, say this is one unsaturated molecule, this is another reactant molecule. Now, this reactant molecule must collide with this substrate at the proper site. That means the reaction occurs by the breaking of this pi bond, so it has to collide from this side. So, molecules must be properly oriented before the collision. If it collides, if this reactant collides the substrate from this side, no product will form. If it collides from this side, no product will form. If it collides from the same side but in the reverse direction, then also no product will form. So, probability or steric factor is introduced in collision theory. What is that? Reactant molecules must orient properly so that molecules can collide at their active site. Then only the product will be formed. So, rate constant K is not is equal to ZQ, is equal to PZQ, where P is the probability or steric factor. It is applicable for complex molecule. So, PZ e to the power minus EA by RT. K is the probability or steric factor, and this P depends on the geometry of the molecule. Now, our fourth question was, why the rate of transformation increases with temperature? According to Maxwell's law of distribution of molecular velocity or energy, because kinetic energy is half mv square, that means proportional to velocity. Less number of molecules will have low energy, less number of molecules will have high energy, maximum number of molecules will have medium energy. Now, if you increase the temperature, then curve will become like that. So, look at here. At low temperature, this less number of molecules have high energy, but high temperature, more number of molecules or more percentage of molecules have high energy. So, at high temperature, more percentage of molecules possess high energy. So, after acquiring this activation energy, more number of molecules can reach to the threshold energy level. So, as more number of molecules can reach to the threshold energy level at high energy, after collision, they can produce more number of products. And at low temperature, when less number of molecules reach to the threshold energy level, then less amount of product is formed. That means rate of the reaction increases with temperature. So, according to Maxwell distribution of molecular velocity or energy, higher fraction of molecules possess high energy at higher temperature. Hence, more number of molecules reach to the threshold energy level after acquiring activation energy. Consequently, more number of successful collisions among the reactant molecules are possible at higher temperature, which results more product formation. Now coming to the last part, that is silent features of collision theory. Now, collision theory is applicable to bimolecular gaseous reaction. See this hydrogen iodide molecules, it is second order reaction, bimolecular reaction, and this hydrogen iodide molecules, when they collide in the activated molecules and the collision at the proper site, then they decompose to hydrogen and iodine. Now next one, this already I have discussed, the molecules, if molecules move slowly, that means if the velocity is less, that means energy is less, then after collision also no product will be formed, that means their energy is less. If the molecule moves fast, that means velocity more or energy is more, that means they are in the threshold energy level, then on collision they can give rise to product. So collision between activated reactant molecules can give rise to product. And the last one, not only the energized molecule must orient properly so that they can collide at the active site, then only the product will be formed. So proper orientation of the molecules at the time of collisions. So this is end of this video number 33. Thank you.